presenter, Clyde Baker of STS Consultants, all the way from Vernon Hills, Illinois. And he will discuss the role of peer review in foundation design.
Thank you. Yes, my talk on the role of peer review in the foundation design of the world's tallest buildings is kind of generic. I use a number of case histories, Burj Dubai just being one of the case histories. What do we mean by peer review? The paper presents the author's views based on our experiences on the role of peer review. I'm sorry. One of the problems with trying to stay on time, I prepared this so I could read it. And I wanted to start with the peer review definition. Peer review can be defined in general terms as the process of subjecting an engineer's work, research, or ideas to the scrutiny of others who are experts in the same field. It is commonly used by the editors to select and screen manuscripts or papers submitted for publication in technical or scientific journals. In this situation, the peer reviewer is not involved during the development of the paper, and there is no direct communication between the peer reviewer and the person whose work is being reviewed. The peer review process aims to make authors meet the standards of their discipline and of science in general. However, the peer review process can be used in other areas as well. This talk discusses the author's experience and how the peer review process has been applied to the cost-effective foundation design of the world's tallest buildings. In this case, there is the potential for involving the peer reviewer early in the foundation design process. The goal of any foundation designer is typically to develop a design that is both cost-effective and safe and meets any required settlement and performance criteria. If the peer reviewer's scope includes working with the design geotechnical engineering firm in a collaborative as well as review role, maximum project benefits can result. Some engineering firms on major projects have an internal peer reviewer in addition to their normal checking procedures. The internal peer reviewer has no direct line responsibility, but serves as an in-house consultant because of his recognized experience and expertise. If there is going to be a peer reviewer outside of the design geotechnical engineering firm, it is important that the selected peer reviewer be recognized as competent with an international reputation and recognized expertise. This is particularly important if the peer reviewer is retained by the project developer, as it makes it more likely that the peer reviewer's views will be given careful consideration by the geotechnical design engineer. It is also important that the peer reviewer be a team player with a respectful and professional attitude toward the engineer's work being peer reviewed. This makes far less likely that there will be prolonged engineering disagreements, confrontations, and project delays. At the same time, the peer reviewer must have integrity to speak his mind clearly on controversial engineering issues where there is a disagreement, even when his client prefers the view of the engineer being reviewed. This is particularly important in the geotechnical field where judgment plays a major role in arriving at the appropriate engineering solution. Why retain a peer reviewer? It is anticipated that retaining an appropriately experienced peer reviewer will help ensure that there is no major engineering mistakes or issues overlooked and the appropriate effort has been made to develop both a safe and cost-effective foundation design. Because geotechnical engineering on which the foundation design is based is a mix of art and science, reasonable differences of opinion among geotechnical engineers based on their different experiences and training can be expected. Such potential differences can result in widely different foundation costs and performance. Appropriate peer reviews thus offer the potential to reduce both foundation costs and risks of poor foundation performance. Sometimes projects are set up by the developer so that the peer review consultant is retained at the same time as the geotechnical design firm. Sometimes the developer will require that the geotechnical design firm have an experienced peer reviewer as part of their team and be part of their proposal. At other times, the peer reviewer is requested after the geotechnical design is completed. For a peer reviewer to submit a realistic budget in his proposal, it is necessary to have a well-defined scope with clarity and agreement on the goals of the peer review. The level of detail of review desired needs to be understood by both the peer reviewer and the party being reviewed, as the level of detail and level of required response will affect budget estimates of both parties. First item is the concept designs. This is the best time for value engineering discussions so that all ideas for reducing costs may be considered early in the development stage. Subsurface exploration and laboratory testing program is the next stage. Understanding and agreement on the level of effort exerted in this stage is important. There is a balance between the amount of geotechnical information, both field and laboratory, that can be obtained and the selection of the maximum geotechnical design criteria for most cost-effective design. Periodic desired team conference participation. It is helpful if the peer reviewer can participate in the foundation design conference meetings, workshops, along with the geotechnical engineer, structural engineer, and construction manager. The possible need for site trips for site conferences must be considered and the cost included if desired. Final report review. If the peer reviewer has been involved in the earlier stages as outlined above, the final report review amounts to a confirmation of what has already been agreed to. Foundation drawings and construction specifications. Since at this point all parties are in agreement with the foundation design, peer review is an opportunity to make any comments for improved clarity. If the peer reviewer has particular expertise and experience with the foundation system selected, a review of draft specification permits the opportunity for making any changes that might maximize clarity. Pile load test results review. Peer review of the pile load test results may be particularly important in the event that changes in foundation design may be required. Poor results may require lengthening piles at significant cost, or better than anticipated results may permit shortening piles for resulting savings. Peer review services beyond defined scope. On occasion, when the peer reviewer has some particular expertise or experience that the design geotechnical engineer lacks, the peer reviewer's scope can be added to include actual design work or specifications development. This happened on one of the case histories described below. Potential problems with peer review. Critics of peer review have concerns that competitive jealousies could obstruct objectivity and lead to efforts aimed primarily at enhancing one's own image and prestige rather than enhancing the project goals. Granted that this is a concern to guard against, it hopefully has not occurred on the projects in which the authors have been involved. The list of the case histories I want to mention are listed here. The first one being Petronas Towers. Petronas Towers is a case history where the senior author had considerable involvement as a peer reviewer from early in the design stages. The design team included a local geotechnical engineering firm, which also did smaller scale structural engineering. The developer retained an internationally recognized structural engineering firm, Thornton Tomasetti, For the actual structural design, a schematic profile of the towers and foundation system is shown in Figure 1. The owner defined maximum allowable differential settlement across each tower of just 12 millimeters, and that made cost-effective foundation design very difficult in light of the site geology. The required tower location was immediately above a karstic limestone canyon overlain by siltstone and sandstones that had weathered to a very dense soil material. The canyon had very steep walls resulting in a relatively shallow depth to limestone on one edge of the tower and more than 200 meters at the center of the canyon between the two towers. The peer reviewer was involved in all stages in the investigation and design as outlined above. The review involved two site meetings with the design team and local geotechnical engineering firm, and involved 6 trips working with the local geotechnical engineering firm. Details of the investigation, design, and observed performance in the structures is included in 2 papers listed in the references. When it became clear that a major ground improvement program would be required to make safe construction at this site feasible, and due to the limited experience of the local geotechnical firm with regard to ground improvement, the services of the peer reviewer were increased to include development of a grouting program and the required ground improvement and development of specifications for the grouting program, as well as providing observation services during the 6-month grouting program. This was a potential opportunity for competitive jealousies to arise, but throughout close cooperation with the local geotechnical engineers, any such controversies were avoided. Being involved at all stages in the investigation, testing, and design analysis helped develop the concept of variable length piles designed to accomplish the differential settlement criteria. The end result of the collaborative efforts of the parties involved was foundation performance that exceeded predictions, with total observed settlement less than predicted and maximum differential settlement of less than 12 millimeters. Next case history is the TNC Towers, and I'll run through this briefly because I know we're short on time. Both this project and the next one, which is Taipei 101, had a very experienced local geotechnical engineer involved, and the peer reviewers were called in when after the foundation design was basically completed. Fortunately, because of the competence and experience of the local geotechnical engineer, the basic designs were approved, and the projects were completed and successfully. And in the case of the Taipei 101, they withstood a major earthquake during construction. Burj Dubai, that's what everybody's interested in. We all know it's unprecedented. It's the tallest building in the world, even as it stands. We don't call it the tallest building in the world yet because it's not completed, but it is certainly the tallest building in the world as it stands today. It's built in an area where the foundations consist of relatively soft rock of variable strength and compressibility. The design geotechnical engineer brought on board an internationally recognized consultant to participate in the foundation investigation right from the beginning. In addition, the design architect and structural engineer retained their own geotechnical peer review consultant with whom they had many years of successful experience working together. Both peer review consultants were involved from the beginning of the investigation and participated in design review conferences either by phone or in person. Major issues for review were the rock properties to use in the design friction and bearing, including the rock modulus for settlement prediction, the percent of load carried by the mat, and the length of piles required for adequate bearing capacity and tolerable settlement. Full-scale pile load tests were used to confirm design assumptions. Through the process of peer reviews, it was possible to reduce the pile length modestly at significant cost savings. The pile load tests confirmed the conservatism of the design assumptions. At the time of this, writing this paper, with 80% of the total load in place, the observed settlements are below the most optimistic predictions of both the geotechnical design engineer and both peer review consultants. Clients always like to hear that the settlements are less than predicted, and we're very fortunate they are. The Doha Convention Center is a project that's just really beginning construction at this point. It's scheduled to be 550 meters tall, and as such will be the world's second tallest building. Proposals were requested by the construction manager for both geotechnical engineering design services and peer review services. STS Consultants Limited in their Dubai office was selected as the geotechnical engineering design consultant with a different internationally recognized geotechnical peer review consultant. Thus, the peer review consultant has been able to comment on the different designs, on the different stages of foundation investigation, testing, and design, and is involved in most of the stages described at the beginning of the paper. We believe this review has been important and has permitted responses and modifications to be made while the project is ongoing. The foundation system is a core mat with 4 smaller mats supporting super columns at the corners of the core. All mats are supported on board piles. At the time of the writing of the paper, pile testing program had been completed in the convention center and has actually been now also completed in the tower. Production pile installation is nearing completion in the convention center and will commence shortly in the tower. Chicago. I couldn't give this talk without talking about Chicago. Along with New York and Dubai, Chicago is known as the skyscraper city, where at one time the city had 3 of the 4 tallest buildings in the world. Chicago has lost its title as having the world's tallest building, but is still building very tall buildings like the Trump Tower. In recent years, the city has installed a peer review process which the developer actually pays for, at least in part. In the geotechnical and foundation peer review section, the reviews have often been performed after the foundation investigation and geotechnical report have been submitted for final, foundation design approval. When the peer reviewer disagrees with the geotechnical engineer at this late stage and may want additional work done, it can be embarrassing for the geotechnical engineer who has to go back to the owner or developer for additional funds and explain the required delays. Thus, this after-the-fact review is much less desirable than reviews which can be made early enough to be included in the investigation cost projections. Efforts are now being made to involve the peer reviewer at an earlier stage for his input if it should differ from the design geotechnical engineers. Usually with the recent tall building projects, variations are required to exceed code values. This makes it even more important to include the peer reviewer early on with the request for code variance. Currently, the potentially tallest building in North America is under construction, and the city peer reviewer has been involved, sometimes informally, almost from the beginning. This approach leads to less surprises and happier clients down the road. Conclusions. Peer reviews provide the most benefit for projects of large, unprecedented scale, which may be beyond the norms of local practice, and foundation geology is complex. The best results are achieved if the peer reviewer is involved from the onset of the project. Before closing, I'd like to recognize my co-authors, 2 of whom are in the room right now. Tony Kiefer from Chicago and Khaldoun Fahoum, who is our regional manager here in Dubai. Thank you, guys. And with that, I'll close.